Dear students, today we will discuss about three equations of motion, and here I have drawn velocity time graph. And suppose our graph is from point A to some point B, that is your velocity changes with time. And let us suppose this time interval from where your velocity changes from A to B, let this time interval be t. Okay, t seconds is the time taken, and at when t is 0 your object is already having some velocity, so I'll say that this much velocity is with object initially, so object is having u as initial velocity, and the up to b, so b be this point, so we can say this b when object reaches at point B, so let V be the final velocity up to B. U is the initial velocity and V is the final velocity. So it is accelerated motion as there is change in velocity. And how much is the change? Change is this much velocity U it was already having, and now the final velocity becomes v. So how much is the change? This, let me call this point as c. So bc is the net change, and this is equal to v minus u. So v minus u is the change in velocity. Now we will start our first equation of motion. So first equation of motion is also called as velocity time relation. Velocity time relation. Okay, so we know that since it is accelerated motion, so we can say that a equals to acceleration, a equals to change in velocity per unit time. So change in velocity upon time. So a equals to, so how much is the change? Change is equal to bc. Bc upon time is t. So bc is equal to v minus u, and time is t. So from here we are getting v a equals to v minus u by t, or we can also say it as at equals to v minus u. Okay, so or t equals to v minus u upon a. So I am calling it as equation A, and this one as equation B. Now from equation A, see what we are getting? At equals to v minus u, or you can also write it as v minus u equals to at. So here we can say that v equals to u plus at. So this is our first equation of motion. This is called as velocity time relation. Now moving towards second equation of motion, which is called as position velocity. So this is called as position time relation. So now we are going to find out position time relation, and for position basically what we are going to get, we are getting here displacement. Okay, so let us denote displacement with s. So dear children, don't get confused, s is not speed but s is displacement. So displacement, graphically we can find out displacement, and that will be equal to area under graph AB. So this whole area will give you displacement. Okay, so displacement will be equal to area under graph AB. Area under graph AB. And I'll divide this area into two sections. This is triangle and this one is rectangle. So if I add area of triangle ABC, and let me give the name, let this point be D. Okay, so area of this triangle ABC and area of rectangle OACD. So this will be equal to area of rectangle OACD plus area of triangle ABC. So now you know the formula of area of rectangle. It will be length into breadth, okay, or breadth into length, whatever you want to say. So breadth is OA into length is OD plus area of triangle ABC. So this will be equals to half into base. So how much is base? Base is this one, AC. Half into AC into height. Height is this much, BC. So it is further equal to, now what is the value of OA? This is equal to U into, and OD equals to T. U into T plus half into AC. So AC, it is equal to T. Half into T into BC. BC is V minus U. Okay, so since it is position time relation, so we will try to omit this term V minus U. So from here we are getting, see, V minus U equals to 80. Okay, so we will put the value of V minus U from equation C. So see what we are getting, S equals to UT plus half T into V minus U is equal to 80. So it becomes, so here from here we are getting S equals to UT plus half AT square. Okay, so this one is our second equation of motion. Okay, now we will move towards third equation of motion, which is also called as third equation of motion. It is called as position velocity relation. Position velocity relation. So position again means, for position we have to find out S. So S displacement means it will again be equals to area under graph AB. So S equals to area under graph AB. But see, this time we will take this whole area. In the previous equation, what we have done, we have divided this area into two sections, but this time I am taking this whole area. So this shape is a kind of trapezium. So we will write it as area under AB will be equals to area of trapezium OABD. So it will be equal to area of trapezium OABD. Okay, so it will be further equal to, now area of trapezium, it is equal to half into sum of parallel sides into height, or you can also say it as half into sum of parallel sides into perpendicular distance between these two parallel sides. So see, here it is half into sum of parallel sides. So these are two parallel sides. So it will be equal to half into sum of parallel sides. So here we have parallel sides as OA and BD. So half into OA plus BD into perpendicular distance between these two parallel sides is OD into OD. So here we will now put the values of these. So S will be equals to half into, so OA is equal to U plus BD is V into OD is T. So see what we are getting, S equals to half into U plus V into T, or we can also write it as half into V plus U. U plus V can be written as V plus U into, this time we will omit this T. So see, from equation number B, so from equation B t equals to v minus u upon a. So we will put the value of t equals to v minus u upon a. So see what we are getting. It is, so s equals to u plus v into u minus v upon a, or I'll transpose 2 and a toward this side, so it will be 2as equals to v plus u and v minus u. So sorry, it is v minus u and it was v plus u. Okay, so this becomes the identity a plus b into a minus b. So it is a square minus b square. So v square minus u square. So from here what we are getting, v square minus u square equals to 2as. So this is the third equation of motion, which is also called as position velocity relation. So just once again we recapitulate all the three equations. So first equation is v equals to u plus at. Second equation is s equals to ut plus half at square, and third equation is v square minus u square equals to 2as. So now dear children, you are supposed to learn these three equations of motion. You should also know how we have derived these three equations of motion. So you are supposed to make notes how to derive these three equations of motion and learn these three equations. And in next video we will discuss how to solve numericals based on these three equations. Thank you.